Welcome to lesson 1. We're in unit 6 right now, and we're looking at exponents. We're going to be looking at exponential equations as well as word problems, but first let's review some topics from grades 9 and 10. So you'll recall that when I have two powers with the same base, when I multiply them together, what happens is that I add the exponents. So I'm going to get a to the exponent n plus m. When I divide, I'm going to subtract the exponents, and when I raise a power to an exponent, I multiply the exponents. So that's a review from grade 9. In grade 10, you learned some extra facts. The first one was notably that anything to the exponent 0 is going to be 1. Now, there is an exception because a cannot be 0. And I would recommend that you try plugging that into your calculator and see that what I'm saying is indeed true. Second one is whenever I have a negative exponent, so a negative integer, I can rewrite that as 1 over a to the exponent n. And lastly, if I have a fraction with a negative exponent, it's the same principle. I just reciprocate my fraction and I rewrite it with a positive exponent. So let's look at some examples of this in action. So in this expression here, I'm going to apply, let's see, my first law I'm going to apply over here. I want to bring in that 2, so I distribute it throughout the numbers within the second set of brackets. So everything will be the same for now, but this part will be x to the exponent 6 and y to the exponent 10, because I'm multiplying every exponent by 2 in that first set of brackets. Then I have x to the 8 and y to the 7. In my next line of work, I'm going to combine the numerator together. So what I do is I add the exponents with the common base. So 4 and 6 gives me 10. And then 3 and 10 gives me 13. And that's all over x to the exponent 8 times y to the exponent 7. And finally, I'm left with just some simple division, in which case I'm going to subtract the 10 and the 8. So I get x to the exponent 2, and I'm going to subtract the 13 and the 7 to give me y to the exponent 6. And there is your first problem there worked out for you. For the second one, again, I would recommend you try these on your own first before seeing the solution. You could pause it here if you'd like. What I'm going to do is combine my numerator first, as well as bring in that exponent into my denominator. So let's do each one step at a time. So the numerator, I'm going to combine the coefficients first. So I have that negative 4, and I have that 8. If I multiply them together, I get negative 32. As well as these numbers, if I combine them together, I add the exponents to give me x to the 6, and finally y to the exponent 8. Remember, there's a 1 assumed to be there. It's not written in. Just like multiplying by 1, you don't write times 1. So we're assuming an exponent of 1. In my denominator now, I'm going to raise everything to the power of 2, and that includes this 4. So 4 squared is going to give me 16, x to the 4, y to the 6. And can I simplify this? Yes, 16 goes into 32 twice. The x to the 6 divided by x to the 4 drops the exponent down to 2, and same thing with the y. So there is an example from grade 9. Here's a few from grade 10. And these ones are actually a little bit simpler in terms of number of steps involved. Again, with a negative exponent, I just reciprocate it, and I raise everything to the exponent of 3. And that gives me 1 over 8. Because 1 times 1 times 1, that's 1 multiplied by itself 3 times, gives me 1. And similarly, 2 times 2 times 2, that's 2 multiplied by itself 3 times, gives me a value of 8. For B, I'm going over here, same thing. I'm going to reciprocate my base, so I have 1 over negative 4, all to the exponent of 2. 1 squared is 1, negative 4 squared is 16, and we're done. For C, I have a fraction, so I reciprocate the fraction to give me 5 over 4, close bracket, squared. And that gives me, if I square the numerator and denominator, 25 over 16. That can't be simplified. I would not recommend you put that into decimal unless it's a word problem. So 25 over 16 is my final answer. And for D here, same idea. I have a negative exponent, so I'm going to write 3 over 1, close bracket, to the exponent 5. And then well, 3 over 1 is just 3, and that's the exponent 5. And if I multiply 3 by itself 5 times, I get 243. So those are your easy ones from grade 10. Let's look at a few more complicated examples. So this is from a grade 10 test. Again, I would recommend you try it first on your own. I'm going to actually do a few operations within each line. So the first one I'm going to do is with this term, I'm going to reciprocate that 2 and raise it to a positive exponent. So I'll have 4 multiplied by 1 over 2 to the positive 3. Now remember, anything to the exponent 0 is going to be 1. And then this exponent, this base here, I reciprocate it, write it to the positive 3. So let's actually do some calculations now. 3, when I raise that base to the exponent 3, I get times 1 over 8 plus 1. I'll leave that there for now. 4 cubed is 4 times 4 times 4, which gives me 64. And 4 times 1 over 8 becomes, remember that's 4 over 1, so that gives me 4 over 8. 1 plus 64 is 65. And let me bring this a little bit over to the side. And I get 1/2 plus 65. Or I'll just write 65.5. Again, I'm writing that as a decimal because it's a terminating decimal, and that's okay. So there is part A. Now for B, again from a grade 10 test, same thing. I'm going to do a few steps in one line. So I'm going to reciprocate the 4. So I have 1 over 4 squared. Anything to the exponent 0, in this case 7, is going to be 1, times 5 over 4, and I'm going to square that. So 1 over 4 squared gives me 1 over 16 plus 25 over 16. If I add those together, I get 26 over 16, which simplifies to 13 over 8. So those are your warm-up questions from grade 10. We're going to start looking at some different type of exponents on the next page. Okay, so we're going to finally start on the grade 11 material now, and we're going to start by doing a little investigation. So what I've done here is I've set up 4 kind of mirror type questions, and we're just going to evaluate them. So to save you the hassle, I plugged this into my calculator and I got, and this is rounded by the way, if I raise 5 to the exponent of 0.5, so we're not using integer exponents for a change, I get roughly 2.23. So 2.23, and that's approximate. With 25, I get the exact number 5. With 81, I get the exact number 3. With negative 243, I get the exact number negative 3. So let's see if there's a pattern here. So what is asked in the next part is to rewrite each of these terms on the left-hand side, the decimal exponents, in terms of fractions. So what they mean is, well, 5 to the 0.5 is the same as 5 to the power of 1/2. 25 to the 0.5 is the same as 25 to the exponent 1/2. 81 to the 0.25 is the same as 81 to the exponent 1 over 4. And negative 243 to the 0.2 is the same as negative 243 to the 1 over 5. Now, if you look closely, you'll notice that there's a pattern here. Let's take B, for example. If I take my answer over here and raise it to the exponents of this base, I get the 25. Same thing over here. If I take the 3, which is my solution, raised to the exponent 4, I get 81. And finally, same thing over here. If I take negative 3 and raise it to the exponent 5, I'm going to obtain negative 243. So it looks good. Can we generalize from this? Well, yes. Basically, if I have a to the exponent 1 over n, that's the same thing as what we call it taking the nth root. Okay, the nth root of the base. And to do this, you will have to know how your calculator functions in terms of expressing fractional exponents. Every calculator is different, so if you do run into difficulty in terms of understanding that, you should probably come to me and we can sort that out. Now in general, we can also write a power with a fractional exponent where the numerator is different than 1 in two ways. We can write a to the exponent m, and that's the nth root of that term, or I can write the nth root of a and then raise that whole thing to the exponent m. They're the same thing. So let's look at some examples here. Here I have 64 to the negative 1/2. Well, the first thing I have to take care of the negative exponent. So what that means is I'm going to rewrite it as 1 over 64 all to the exponent 1 over 2. Now we just saw from above that when I take the 1/2 as an exponent, it's the same as taking the square root of 64. Now the 2, which I would normally write over here, is not written. Okay, so whenever we have a square, we don't write that 2. It's assumed to be there. And if I take the square root of 1 and the square root of 64, I get 1 over 8. For the second one, I'm looking at the cube root of negative 125. So I set this up as cube root negative 125. Again, your calculator will dictate the answer to this question as negative 5. So I did this beforehand. This would be an example of a cube root over here, and this would be an example of a square root. Let's look at another one. So here's an example where we're using the rule indicated previously over here. So we want to apply this rule to this question here. You'll notice that 2 and 3, the 2 acts like an n, or is it an m? M, my apologies. The 2 acts like an m. This is like our m value. This is like our n value. So when I do the math, well, I'm taking the nth root, or the cube root, of 27, and that's all to the exponent of 2. Well, the cube root of 27 is 3. 3 squared that is going to give me 9. Keep going. So in D, same thing, except I have a negative base. So I'm going to rewrite this as the cube root of negative 27, and that's all to the exponent 4. Negative 3 is my cube root of 27, negative 27 to the exponent 4, and that gives me 81. Final example, this is a little bit more involved, but not impossible. I'm going to, let's see here, I'm going to evaluate each term one at a time. So this 16 3/4, I'm going to rewrite it as the 4th root of 16 to the exponent 3 plus 8 to the exponent 5 over 6 times 8 to the 1/2. Now what I did is I replaced this root sign with the equivalent exponential version or exponent version of that expression for the radical. And then finally minus, let's reciprocate this, 1 over 81 to the exponent of 1/4. So let's start evaluating some stuff. The 4th root of 16 is 2. Okay, 2 to the power of 3 is going to give me 8. Plus, I need to combine these together, which means I have to add the exponents. So I have 5 over 6 plus 1 over 2, which we'll do in the next line. And then finally minus the 4th root of 1 over 81. So I still have my 8 here, plus this will become 8 to the exponent, let's see, 8 over 6 minus 1 over the 4th root of 81 is 3. Now I'm looking at, let me simplify this fraction here. So this 8 over 6, I could have rewritten it as 4 over 3. So that would be the cube root of 8, close bracket, to the exponent 4 minus 1 over 3. Well, the cube root of 8 is 2, and 2 to the exponent 4 would give me 16. And so my final answer, well, almost there, I got 24 minus 1 over 3, which will give me, let's see, 72 minus 1 over 3, which is 71 over 3. Again, a bunch of elementary math going on there. Perhaps I did it rather quickly. Try doing it on your own to convince yourself that that is indeed the answer. So there are your examples for lesson 1 of Unit 6. Homework is below. Get started on that because we got a little bit more difficult material coming up in the next few days.